Hi ladies and gentlemen, this is Miss Skokin. We're going to be starting a very short unit on radical expressions and radical equations, and we're going to start with simplifying radical expressions. Let's start out by refreshing our memory that we can write a number in such a way that it is built by two parts. One of the parts is the base, and the other part is the exponent. And the base is the number that we're going to multiply. The exponent is how many times we're going to multiply it. So if I've got something that looks like 4 to the third power, or we could say 4 cubed, that means I'm going to take the number 4 and I'm going to multiply it 3 times. Now, 4 times 4 is 16. 16 times another 4 is going to be 64. So 4 cubed, or 4 to the third power, is 64. Notice this is not the same thing as 4 times 3, which is 12. So just a reminder, the base is the number we're multiplying. The exponent is how many times we're multiplying it. Now you'll notice that this section is about integer exponents, which means we can have both positive, negative, and zero exponents applied to our base. So we've got a little table here. We're going to fill out that table, and we're going to start with the column all the way on the left, which reads 2 to the 5th power. 2 to the 5th power means that we are multiplying the number 2 1, 2, 3, 4, 5 times. And so what we can do is we can do it in a lot of different ways. We know that multiplication is commutative and is associative, so we can start out by saying 2 times 2 is 4 times another 2 times 2. So these are 16, and then we take that 16, multiply by the last 2, and that gives us 32. So 2 to the 5th power equals 32, and our exponent is 5. When we look at the next column, we have 2 to the 4th. So 1, 2, 3, 4 2s, 2 times 2 times 2 times 2. We know that this is going to be the same as 4 times 4, which of course is 16. This time our exponent was 4. Now I want you to notice the pattern. Our exponent decreased by 1. You'll also notice the relationship between 32 and 16. 16 is half of 32, or 32 divided by 2 gives us 16. Let's move on to the column to the right, 2 to the third power. We can also say that as 2 cubed. We know that that means 2 times 2 times 2, which of course is 8, or 4 times 2. Now this time our exponent is 3, and you'll notice again the exponent decreased by 1, and the result of applying the exponent to the base for 2 cubed is half of what we got previously, 16, for 2 to the 4th. All right, let's continue moving to the right. Let's skip around just a teeny bit. We notice that what we're doing is we're decreasing the exponent by 1 each time, and what I want us to do is fill in that bottom row to begin with. So 3, let's see so you can see the whole table. 3 minus 1 is 2. Another minus 1 is 1. Take away another 1, we end up with 0. Take away another 1, we end up with negative 1. And of course, another subtraction by 1 is going to give us negative 2. What this means is, you can see those numbers in that bottom row are the exponent that we're going to apply to the base of 2. And so we're going to have expressions that read 2 squared, 2 to the first, 2 to the 0, 2 to the negative 1, and 2 to the negative 2 power. Okay, now we're going to fill in the third row from the top, and that's going to give us kind of the result when we apply the exponent to the base. So 2 squared we know is 4. We also know that that means 2 times 2. Now remember what we said, that each time as we go from left to right, as we're decreasing the power by 1, what we ended up doing was dividing by 2 each time. So I'm going to fill that reminder in. You do the same on your notes. So we know we're dividing by 2 to get to the next block. Okay, when we divide by 2, what's going to end up happening each time? Well, let's take a look. So if I take 4 and divide by 2, 4 divided by 2 is 2. When I do 2 divided by 2 to get to the next column, it's going to be 1. We know anything divided by itself is going to be 1. When I take 1 and I divide by 2, that one might not be obvious to you, but that's going to be 1/2. And we take 1/2 and we split that in half, and that's going to give us 1/4. Just a little bit of a review of the meaning of the fractions there. Okay, now let's write the way that this looks when we expand the exponent. So when we have 2 to the first power, we know that that's just a 2. 1, 2. And when we have 0 2's, we know the result is 1. So even though we can't see the 1 that's multiplied to the 2 to the 0 power, it's always there. It's almost as if every number that we see we're multiplying by 1. And we know that 1 multiplied by anything, that's the identity. It's an identity of multiplication. And so we know 2 to the 0 times 1 has to equal 1. So that means that 2 to the 0 also has to equal 1. When we come to 2 to the -1, you may or may not remember that the notation for this was the negative exponent means you're in the wrong place. So if you're in the numerator like we are here, it means you need to be in the denominator. So we're going to use that reciprocal, and it's going to be 1 over 2 to the first power, or 1 over 2, which of course is the result that we wrote down. Oopsie, here. Okay, and last of all, when we have 2 to the -2 power, that really means that 2 needs to be in the denominator, and it's 1 over 2 squared, or 1/4, which of course is what we got a little while ago. So this is a little bit of a review of integer exponents. Let's take a look now at the exponent rules that we learned in a combination of pre-algebra and algebra 1. We saw a few minutes ago when we were filling out the table that when we raise something to the 0 power, we end up with a 1. So any number to the 0 power is going to get a 1. Let's take a look at the example. In this case, we have 121 times x to the 5th times y cubed times z squared, and the z squared is raised to the 0 power. That means this is going to be equal to 1. So the result of multiplying all those things together and multiplying to 1 is going to be 121 x to the 5th y cubed. Okay, there is a now you try, which means you're going to pause the video and work on that question, and when you're ready to check your work, you're going to turn the video back on. See you back in a minute. The next rule, where we're raising m to the first power, you may remember anything raised to the first power is that same base number. So m to the first is m, and here we have this, everything in this parentheses is being raised to the first power, and that means that it's going to be a result of 9/5 times a cubed times c to the 4th. Okay, now we're ready for a now you try. You're going to pause the video and check your work when you turn the video back on. The next rule, you might need to have your memory refreshed just a little bit, and this rule tells us that when we have two numbers that have the same base and they're being multiplied to each other and they're both powers, then what we're going to do is add the exponents. So we're going to have the same base, m, but the exponent is going to be a plus b. In the example that we've got, we see that we have the same base, 3. We have it for 3 different numbers, And so what we're going to end up with is a base of 3, and we're going to add those exponents to one another. So 2 plus 5 is 7, minus 4 is 3, so we're going to have 3 cubed, which is 27. Okay, now you're going to pause the video and work on the now you try, and then turn the video back on to check your work. See you back in a minute. This next rule shows a power or a base with an exponent being raised to an exponent. So the rule for this is we're going to multiply the exponent. So this is going to have that same base of m, but the exponent is going to be a times b. In the example, we've got x over y, which is being squared, raised to the 2 power. And then we raise that whole number to the 7th power, which means we're going to have the same base, x over y, but it's going to have an exponent of 14, 2 times 7. So x over y to the 14th power. We need to have the parentheses in there just so that you're observing the reason for the parentheses, and that is because the exponent applies to both the numerator and the denominator. So if we didn't have it, it would be on the numerator only and not the denominator, and of course that would not have the same value. Now you're going to pause the video and work on the now you try. Turn it back on when you're ready to check your answer. The rule in purple, where we had two numbers that had the same base and both had exponents, you remember that we ended up adding the two exponents. This time we're not multiplying two numbers that have the same base, we're dividing two numbers that have the same base. And that means that instead of multiplying, we're going to be, instead of adding the two exponents, we're going to be subtracting the two exponents. So we're still going to have the same base, m, but this time the exponent is going to be a minus b. Now we don't know what a and b are, so that's as far as we can go with that one, but we can try out the example. Now what I want you to do is kind of look at it in pieces. It's almost as if we have three different numbers in our number because we have three different variables. So we're going to take them in turn. We have x to the 4th over x cubed, meaning we're going to have x raised to the power 4 minus 2. That is going to be multiplied by y, which is the common base, to y to the 5th and y squared, and it's going to be y to the 5 minus 2. And then last of all, that's going to be multiplied by z raised to the 2 minus, and remember, if we don't see the exponent, we have an exponent of 1 there. So our final answer for this one is going to be x squared times y cubed times z raised to the 1st power, so we don't write that exponent. Okay, great opportunity for you to pause the video now, work on the now you try, and turn it back on when you're ready to check your answer. The last rule we've got listed here is the m to the negative a. Remember that negative exponent is telling us we're in the wrong position, so this is actually going to end up being the reciprocal, which is 1 over m raised to the a power. In our example, and it looks a lot like the example that was right above, again we have x's, y's, and z's that we're going to look at all separately. So starting with the x's, we're going to have x raised to the 2 minus 4 times y raised to the 5 minus 5 times z raised to the 2 minus 1. Now this is going to give us x to the negative 2 times y to the 0 times z to the 1st. We're not in our final form here, and x to the negative 2 power means that x needs to be in the denominator with a power of 2, y to the 0 power is equal to 1, and z to the 1st power is equal to z. So the result is going to be z over x squared. Okay, time for you to pause the video and work on the now you try. Turn the video back on when you're ready to check your answer. That gave us a little bit of a review of radical expressions. I'll see you back for the next video.